So now we are live as usual. All right. If you guys have any questions on the homework assignment that was given, I'll be more than happy to answer them now. If not, we just select a couple of problems and walk through them with you. Is there any question on that assignment? For those who came in late, I am lecturing now from Cameroon, from my village, where I have some personal things to handle. And I will be back to US in 2 weeks. All right, if there is no question, let us go straight to the deal. One type of question that you have on this assignment is find a limit using series. When you're asked to find a limit using series, there is nothing but that is required. Anything else that you do is 1-0. There's no partial credit when you don't follow the question that is asked. How should we answer this question? We look for the functions that are in there that we can write down the power series of, and we write their power series, we substitute in that limit, and then we simplify and find the value of the limit. Here, for instance, we have x to the power 4. This is already a power of x, no problem. E to the x squared. This is the function that gives us trouble, and we need to write that function as a power series. So, if we want to answer this question, we will have to find the power series of e to the x squared. What is this equal to? In order to do that, you need to know the power series of the standard function. For instance, in this case, you need the power series of e to the x. And that is 1 plus x squared over 2 plus, and so on. I don't need to go further because I'm going to plug in x squared and obtain what I need. And so in this case, if we do this, what we obtain is e to the x squared equals 1 plus x squared. We replace x by x squared. So you got e to the x squared minus 1 over 4x to the fourth is equal, and then you replace there minus 1, you get x squared plus x to the fourth over 2 divided by 4x to the fourth. And this gives you 1 over 4x squared, because x squared divided by 4x to the fourth is 1 over 4x squared, plus you divide this one, you get 1/2 divided by 2, that's 1/8, plus, and everything that is coming after that goes to 0 because the power is higher than that of x to the power 4. So they divide and you get a number that goes to 0. And so the limit when x goes to 0 of e to the x squared minus 1 over 4x to the fourth equals limit when x goes to 0 of 1 over 4x squared plus 1/8. And when x goes to 0, x squared goes to 0, but it's positive. When over a positive 0, that's infinity. Infinity plus 1/8, this limit is infinity. Well, unfortunately here, everybody plays music the way he wants, so I had to go tell the neighbor to reduce the volume here. All right, is there any question with this one? All right, if not, now let me give you an alternative to solve. Find using series limit as x goes to 0 of cosine of x squared minus 1 over x to the fourth. 3 minutes for that, please. Have the answer, Nicholas?
I don't actually. I have a question about it. Is cosine x squared cosine of x squared, or is it cosine of x and then the whole thing squared?
No parentheses, so it's only x that is squared. Want to try, Eric? Jason, are they here?
I don't remember what the series is for cosine.
It's going to ultimately somehow be on that test. So that's the time to look for it when the question is asked. If you don't, Matthew, okay, Nicholas, go on.
The first thing I did was I defined the Taylor series for cosine of x, which was 1 plus x squared over 2 for what we need for it.
Need at least one more term to see that the extra terms are going to be go to zero. So that is one. And as x squared over 2, what's the next term?
X to the 4th over 4 factorial.
That's it. Now you keep that, and then you plug in x squared. That's 1 minus x to the 4th over 2 plus x to the 8th over 4 factorial. And now you can have cosine of x squared minus 1 over x to the 4th equals minus 1 goes there over x to the 4th. That's minus 1/2 plus x to the 4th over 4 factorial. And then clearly, it's seen that these terms here are going to go to 0. So you have limit as x goes to 0 of cosine x squared minus 1 over x to the 4th equals limit as x goes to 0 minus 1/2 x to the 4th over 4 factorial. And this limit, because this term goes to 0 and all of this goes to 0, the limit is -1. So the other type of question that you have is identify the function that is represented by the series. So we want to identify the function that is represented by the series sum k from 1 through infinity, -1 to the k, for example, k x to the power k plus 3 over 6 to the power k. Now, any of these problems depends on your skills on series, what you know and what you don't know. So when I look at this, I see a k that is down here. And if I see a k that is down here, that is telling me that probably there was a derivative somewhere, derivative of something, because that's how I get k down from the rules of derivatives of series. So I need to write this in a form that will get me a derivative. And so for k to be here, the power needs to be k minus 1 for the series, because the power series of the derivative is sum of ak times k times x to the power k minus 1 when you take the derivative. So I need to have something to the power k minus 1 to make sure that I am on track for the question, which means instead of power k plus 3 here, I need to get out some of the x's and make sure I keep inside here the power k minus 1. And to do that, that means I need to get out x to the power 4. So if I get out x to the power 4, that's going to be sum k from 1 to infinity, negative 1 to the k times k times x to the power k minus 1. This is what you get. And once you get here, you have 6 to the power k that was below, and you keep it there over 6 to the power k. Now, once you get this, you can make sure you have the same power for these two to put them inside and combine them to get one single thing. So that's going to be x to the power 4, and then sum k from 1 to infinity, negative 1 to the power k, and then x over 6 raised to the power k minus 1. And then, because it's power k, you still have a 1 over 6 that is there. And if you look at this carefully, you will see k x over 6 to the power k minus 1, then 1 over 6, that is the chain rule. That's the chain rule for the derivative of x over 6 to the power k. So what is inside there is nothing but the derivative of x to the x over 6 to the power k. So this is sum k from 1 to infinity, negative 1 to the power k, and then what is there is the derivative of x over 6 to the power raised to the power k, and then you took the derivative of this. Now from here we can switch the derivative and the sum, so that's x to the power 4 times sum k from 1. And now we can actually add the term 0 in there, because we know that for that term with 0, when you take the derivative, it's 0. So we start k from 0 to infinity, and then negative x over 6 to the power k, and then all of this, take the derivative. So this thing is exactly that, because we just switched the derivative and the summation. But now using the geometric series, this sum that is inside the derivative is nothing but 1 over 1 minus the ratio that is inside. So that is 1 over 1 minus negative x over 6 using geometric series, and then take the derivative of that, because that's the derivative standing outside. So you don't just force to get that answer because you repeated and you saw that it is that. Now, after doing this, what you obtain is x to the 4th times derivative of 1 over this, that's going to be minus the derivative of 1 over 1 plus x over 6. That derivative is going to be 1 over 6 divided by 1 plus x over 6 squared. So this is what it is, and that is negative x to the fourth over 6 times 1 plus x over 6 squared. So that's the function that is represented by this power series. Any questions? Are we on the same page in class? Nick,
Oh, yeah.
are we okay? So this is what you should be able to repeat on that, using the properties of limits and derivatives of power series, how you can switch the derivative and the summation to identify the function that is represented by the derivative. Let me give you a second problem on which I would like you to apply this. So the next problem is same question as the previous one, just with a different series. Identify the function represented by the following series, and the series is sum k from 1 to infinity x to the power 6k over k. It's the same kind of question, but this time with a different twist. I guess here the twist that you could use would be the derivative, the integral, or if you don't want to use the twist of the integral, you could use the power series of another known function, whatever you want. So take 5 minutes, please, to work this out. So please let me know when you have something you can want to share. Who wants to try?
I can give it a shot.
All right, listening.
So, with the starting series of x to the 6k over k, would you want to take the derivative of that function with respect to k to get rid of k on the bottom, or should you integrate at the very
You could do
beginning?
that. You could do that. Whatever you do that works. Taking derivative is valid.
Okay, so that's what I did at the very beginning.
Mhm. So you first say you will call this f of x, and then you do f prime of x to find the derivative before you recover the function itself. That's technically the idea that you have. Okay. So now you take the derivative of this is going to be sum k from 1 to infinity. And what's the derivative of that?
Would it be 6kx to the x, or 6k
Okay,
minus 1 over k?
the k's cancel. So that's, and what next?
At this point, do you have to get rid of the k minus 1 in the exponent to be able to bring it into a function?
So you're taking technically what, 6 over x out. That's sum k from 1 to infinity, x to the power 6k. What next?
Can you take x to the 6k and convert it into a function and then multiply that by 6 over k, 6 over x?
Well, how is that? How do you, what is the function that represents this?
Is the power function that represents x to the k 1 over 1 minus x?
This is sum starting from 1. And the power series is for sum starting from 0. So something is missing there that needs to be integrated before you apply the 1 over 1 minus x thing. Again, what I'm saying is that sum k from 0 to infinity of x to the power k, that is 1 over 1 minus x. You need k to start at 0, and here it starts at 1. What do we do?
You change the exponent to 6k minus 1 and then integrate it then?
No. What is missing? What's missing in this sum?
The 0 would be missing on the bottom of the notation.
What does it mean? Sum starting from 0 and then sum starting from 1. What is missing in this sum that should be in the other one?
Is it that first term
That
for
first
k equals
term,
0?
right? So you add it and you subtract it. So the first term is missing, so that's 6 over x, and that is, you subtract that first term, which is 1, and you add it to the summation, sum k from 0 to infinity, x to the power 6k. Now this thing is same as that, but this sum now is what you were saying, 1 over 1 minus x to the 6. So this whole thing is going to be 6 over x times negative 1 plus 1 over 1 minus x to the power 6, because this is that sum. And that is negative 6 over x plus, and we can actually add these two. We can first add this 2, okay? So negative 1 plus 1, they cancel. And I'm going to have to put them all together. It's going to be 6. So that's minus times the minus, that's a plus. 6 times x to the 6 over x times 1 minus x to the 6, which is 6x to the power 5 divided by 1 minus x to the power 6. All right? So you have f prime of x equals 6x to the 5th over 1 minus x to the minus 6. I'm sorry, x to the 6. Therefore, you can have that f of x equals to the integral of 6x to the 5th over 1 minus x to the 6th dx. And you take this integral, and this integral is negative natural log of 1 minus x to the 6. And now we would have got plus a c, and then plug in the x equals 0 value to get that c is 0. I'm stopping here because I do know that f of 0 is 0. Otherwise, you would say plus c. And for this function that is defined here, f of 0 is by plugging in x equals 0. When you plug in 0 with the coefficients k starting from 1 to infinity, all those powers are going to be 0. So f of 0 is 0. And you use that here to say 0 equals negative natural log of 1 plus c, and log of 1 is, a natural log of 1 is 0, so you get c equals 0. So you get f of x equal negative natural log of 1 minus x to the 6. So this is what you get from working out the problem. On the other side, if you look at what we did in class before, An alternative answer to this problem would have been take x to the power 6 equals t. If you replace that, then you have f of x equals sum, okay, from 1 to infinity, t to the power k over k. And when we did this, we already did this in class and we figured that's negative natural log of 1 minus t. And t is x to the power 6. You would have got that same answer that I got here. But here, this answer uses a fact from the class notes, and this answer is straightforward without no extra knowledge from the class notes. Questions? All right, if you guys have no question, let me look at the next topic. The next topic is question 3. Area in polar coordinates. And so the question is, make a sketch of the region and then find the area. All right. So here, make a sketch and find the area of r equals 4 plus 2 cosine of theta. And this question is in 2 parts. Sketch, then find the area. Sketch, I show you how to sketch. How do we do that? We first need to solve r equals 0 and r prime equals 0. Sketch. So that's answer. Sketching. Solve r equals 0, r prime equals 0. So r equals 0 here gives us 4 plus 2 cosine theta equals 0, which leads to cosine theta equals -2. In this case, there is no way cosine theta can be equal to -2, so there is no point where r equals 0. And if there is no point where r equals 0, that means that the curve doesn't go through the origin. It doesn't go through the origin. And then we can solve r prime equals 0. And r prime is obtained by taking derivative of this. So that's r prime equals -2 sine theta. Solving this equal to 0 amounts to sine theta equals 0. And sine theta equals 0 means theta equals k pi. And I do want you to make sure you properly solve this using these k's as integer, then plugging them in to figure out what you get as answer. Otherwise, you try to go the easy way you might always miss things because you're guessing, you don't know exactly how to solve the problem. So in this case, we've got this. And now you plug in the values of k to see how many times you're gonna get that zero sign. And here, that's first one, k equals 0, of course, you get theta equals 0 if you plug in k equals 0. If you plug in k equals 1, you get pi. And if you plug in k equals 2, you get 2 pi. And in terms of polar coordinates, 2 pi and 0 represent the same point in angles. So you have restarted at this point, so there's nothing else. There are only 1, 2, 3 options with the two end points being same. Now, with that being said, you gotta compute r of 0, knowing that it's r of 2 pi. That's why I was saying that it will be the same point. You plug that in, it's gonna be 4 plus 2 cosine of 0, which is 6. Then you compute r of pi, which is 4 plus 2 cosine of pi. Cosine of pi is -1, so that's 4 minus 2 equals 2. So the radius here is 2, and the radius there is 6. Any questions? So that means if we want to sketch this thing, and because you don't have extra points, you might pick some numbers between these two to see how it's going, how the curve is going to go. You can take here pi over 2 and take here 3 pi over 2. For pi over 2, if I plug in pi over 2, I get 4. So it's going to be in that direction. If I plug in 3 pi over 2, I'm going to get 4 as well. So they go through the same points along those same length at pi over 2. At angle 0, we are at 6, somewhere there. And at angle pi, we are at 2, somewhere here. And so you start at 0 here, you go up, cross through that guy, came back, cross this guy and go over there, get back there. So that's technically what your curve is going to look like. That's all. And now you got to find the area. You can see that it's one entire loop for the whole thing. So there's nothing that repeats there. And now you want to find the area. Because you go from 0 to 2 pi to cover the whole thing, you are going to have that the area is equal to 1/2 integral from 0 to 2 pi of r squared d theta, which is 1/2 integral 0 to 2 pi 4 plus 2 cosine theta squared d theta. And we need to compute this integral. And that's something like 1/2 integral 0 to 2 pi. Open the parentheses, you get 16 plus 16 cosine theta plus 4 cosine squared theta d theta. The integral of 16 is 16 theta. So that's gonna 16 there. You plug in 0 and 2 pi and divide it by 2. So you'll get 16. You get 16 pi for the first part. Plus, the integral of cosine is sine. When you plug in 0 and 2 pi, you get 0. Then you take the integral of the other. And 2 cosine squared, integral 0 to 2 pi. 1/2 and 4, that's 2. 2 cosine squared theta is cosine of 2 theta plus 1 d theta. That's a double angle formula that we used last time. And so you get 16 pi plus the integral of cosine. It's sine, and when you plug in the two boundaries, you get 0. So the integral of this part is 0, and the integral of 1 is going to give you 2 pi. So the answer is going to get you 18 pi. So the area of that curve is 18 pi. Questions? Hello. All right, guys have no questions. Let me on this side put the problem for you to solve. Similar. We have r equals 5 cosine 3 theta. And then the question is, you got to sketch and area of one loop. Sketch the graph and find the area of one loop. Anyone ready?
I can try the problem.
All right, let's go.
All right, so the first thing I did was solve for r equals 0. So I set 5 cosine 3 theta equal to 0, which meant that cosine of 3 theta was equal to 0.
Mm-hmm.
And then
Oh,
for that equation, I got pi over 2 plus k pi over 3, which is equal to pi over 6 plus k over 3 pi.
go step by step. 3 theta equals what? Pi over 2 plus k pi, right?
Yes.
Then you got theta equals pi over 6 plus k pi over 3. And now you plug in the values of k as you were saying. How many points do you get? Theta equals?
I had pi over 6.
Yep.
And
That
then
one, k equals 0.
I had pi over 2.
How you get pi over 2?
Pi over 6 plus pi over 3.
Oh, so you get k equal 1. So it needs to be clear where we go. When you do that, you get pi over 2 because that will be pi over 6 plus pi over 3 gives you pi over 2. And then you get k equals 2. What you get?
5 pi over 6.
Then you get k equals 3.
And then for that, I got 7 pi over 6.
All right, 7 pi over 6. Then you take k equals 4.
I got 3 pi over 2 for that one.
Correct. 3 pi over 2. And then you get k equals 5.
11 pi over 6.
That's correct. And then if you take k equals 6, you return to the same point. So you don't need to find that. You return to the origin because that's going to be 2 pi plus pi over 6, which in terms of angles is the same pi over 6 here because we want to be within 0 to 2 pi. So you got 1, 2, 3, 4, 5, 6 points only for r equals 0. And then you take r prime equals 0. What'd you get here?
This one I took the derivative of 5 cosine 3 theta, which I got 15 sine 3 theta.
Negative 15,
Negative
right?
15, yes.
Sine 3 theta equals 0. And that gives you 3 theta equals k pi. So theta equals k pi over 3, right?
Yes.
Okay, and now from here you plug in the numbers. When k is 0, you get theta equals 0. Then k equals 1, you get pi over 3. K equals 2, you get 2 pi over 3. K equals 3, you get pi. K equals 4, you get 4 pi over 3. K equals 5, you get 5 pi over 3. And k equals 6, you get 2 pi, which is same as the first initial one's 0. So you get 1, 2, 3, 4, 5, 6 points also. Between any two of them, you put 1 point. So, and now we can try to do the sketch. And before doing the sketch, look at the value of the function at the points where r prime is equal to 0. So you'll find r of 0. R of 0, that's 5 cosine 0. R of pi over 3. 3 times pi over 3, it's pi. Cosine of pi, it's negative 5. Then r of 2 pi over 3, that's 5. Then r of pi, it's going to be negative 5. R of 4 pi over 3, it's going to be what? Times 3, it's going to be 5. And r of 5 pi over 3 is going to be negative 5. And then back r of 2 pi 2 pi is going to go back to 5. So you got these points and they form all the loops that are necessary. And then you try to do your sketch. The interesting angles are the angles first where you get back to 0, which are 1, 2, 3, 4, 5, 6. Then pi over 6, you're gonna have one angle there. And on this side, 11 pi over 6 is gonna be on this side. Right. And when you start at 0, r of 0 is 6. It starts at 6. And it goes down to 0 from here. And in the 11 pi over 6, it also goes back there. So that's a loop. And then you continue drawing 1, 2, 3, and so on. I'm not going to go around all that circle drawing all those things because I need to have time to compute the area. I just draw one loop, okay? And so we will need the area of this loop. And the area of that loop, because it's symmetric, we could say that it is twice. So let's say area. It is twice the area of the part that goes with angle theta equals 0 all the way to theta equals integral from 0 to pi over 6 of 5 cosine 3 theta squared d theta, which is nothing but 25 integral from 0 to pi over 6 of cosine square of 3 theta d theta. So that's how we would find that. And now using the same trick that we had earlier, we can compute this integral. That's 25 integral 0 to pi over 6. And cosine squared is nothing but cosine of 6 theta plus 1 over 2 d theta. So that's 25. Integral of cosine is going to be sine 6 theta over 6. And 2, that's over 12, plus 1/2 theta 0 to pi over 6. When we plug in pi over 6, we get sine of 6 times pi over 6, which is sine of 6 pi. That's 0. Plug in 0, sine of 0, 0. So we are left with 25 pi over 6 divided by 2, 12. So that's the area of one loop. Questions?
Can you scoot the paper up a little? The other way. I mean, my bad.
What?
Can you scoot it down? I meant to say down.
Any other questions? We have any other questions? All right, if not, then we will return to a few questions on parametrization. We can't go over all that. So a question could be, parametrization. 1. Find the parametric equations of the line through P with coordinates 1, -1, and Q with coordinates -2, 3. I think you guys can do this directly before looking at what I would do. So you take please 2 minutes to give me the answer to this. So anyone wants to try?
I can try.
All right.
For this one, I use the equations x equals xa plus xb minus xa, and then y equals ya plus yb minus ya.
Something is missing.
The t after xb minus xa.
That's it. And so here, what do we get?
Once you plug in the values, I got 1 plus or 1 minus 1t for x, and then -1 plus 4t for y. So for the, I used the q, so -2 was xb, and then subtracted 1 from that, so it came out to -1. Or
-1 minus -2 minus
-3.
-3. So that's 1 minus 3t. And then the y, that is -1, and
then it was 3 plus 1, so it came out to 4t.
all right, that's it. That's how it's done. Now the last question could be about tangent lines and slopes. You can have x of t equals t squared plus 5, y of t equals sine t, and I say find the slope of the tangent line at t equals 0 to find all points where this tangent line is horizontal. Okay? And I'm going to answer right to this because we don't have enough time left. So for 1, find the slope of the tangent line when t is equal to 0. You got m equals dy over dx when t equals 0, which is y prime over x prime when t equals 0. So you take y prime, y prime is cosine. I'm sorry here, I can put 5t for me here, okay? The problem is 5t. So y prime, that is derivative of sine t, it's cosine t. Then x prime, derivative of x, that'll be 2t plus 5. And then plug in t equals 0. That's equal cosine 0, 1, 2 times 0 plus 5. So that is 1/5. So this is the slope of the tangent line. Now to answer the second question, find all points where the tangent line is horizontal. That would mean that the slope is equal to 0. That's when the tangent line is horizontal. And that would mean that y prime over x prime equals 0, which is cosine t over 2t plus 5 equals 0. And that leads to cosine t equals 0, leading to t equals pi over 2 plus k pi, where k is an integer. So every time that t is pi over 2 plus k pi, we get a horizontal tangent line. And so you can find x of t for that, x of pi over 2 plus k pi y of pi over 2 plus k pi. I guess here you got negative 1 to the power k. And here you just plug that in. You got pi over 2 plus k pi squared plus 5 times pi over 2 plus k pi. So these are all those points that you get. All right. That's it for me. And if there is no question, I'll see. Good luck. I see you on the test. If you have a question, you stay and ask me.
Thank you, Dr. Longwell.
Welcome, sir.
Thank you.
I'll see you on Thursday.